Hello and welcome back. Our next speaker is Rodolpho Concurde, and he's going to be talking about fuzzing and finding your own bugs and 0 days. So without any further ado, let's pass it to Rodolfo. Thank you again.
Hello everyone, welcome to my talk. I'm glad for being here with you all. My talk is about fuzzing, finding your own bugs in 0 days. My name is Rodolpho Concurde, but you can call me by my nickname ROd0X. A little about me. I'm a penetration tester, instructor IT, consultant of information security throughout 10 years. I'm certified ethical hacker by EC Council. I'm an author at Hacking 9 magazine about Stack Overflow and Pentest magazine about Discovery Channel, from fuzzing to get a shell, and from SE8 override to get a shell. Our agenda. We will see types of targets, types of attacks, types of fuzzers, buffer overflow, and we have a POC. Types of targets might be protocol, FTP, POP3, FSMTP, Telnet, anyone, any protocol. Application, any input of any application. File format, any file format, MP3, MP2, MP4, for test the software's reader. Types of attacks. Fuzzers would try combinations of attacks on numbers, chars, metadata, pure binary sequences. Is sent for the target one list with a sequence of dangerous string. Again, is sent for the target one list with a sequence of dangerous string. And here we have some examples. Types of fuzzers might be dumb or smart fuzzing. Dumb, any string combination. Smart fuzzing. Smart fuzzers are programmed with knowledge of the input format, a protocol definition, or rules for a file format. Smart fuzzing might be mutation, generation, or evolutionary. I won't speak in detail about smart fuzzing due a little time that we have in this talk, but I left here the link for the F-Secure website with more information about smart fuzzing. Buffer overflow. Buffer overflow is an anomaly where a program, while writing data to a buffer, overruns the buffer boundary and overrides adjacent memory location. Might be RIP-based, stack-based. The RIP-based place in the memory which allocates a lot amount of data dynamically. Stack-based allocates a limited or fixed size of data, such as data from local variables or functions. Here we have a code example of buffer overflow. We have here a variable buffer with size 5 bytes. What's the problem with this code? The problem is that this code don't verify what it should do if the user insert more than 5 bytes. So if the user insert more than 5 bytes, you occur as overflowing stack. Here we have two images. Left image is variable full with 11 A's, and the right image variable full with 150 A's. In right image occur an overflowing stack. As we can see, it's overwrite in register ISP and register EBP. So occur here an overflowing stack. Now we have a POC. Discover input format to realize the fuzz. Example of protocol POP3. Here we have command user and command path. Each protocol has their own command. In this case, the protocol POP3 we have a specification in document RFC1081. Each protocol has your own document with your own specification. This protocol POP3 has specification in document RFC1081 that the protocol POP3 use a command use and command pass. Let's see the POC video. Let's see the POC video. Let's run in the nmap command against the target IP. And we see that it has port 110 as open. It is running a service POP3 in port 110. Now here we have a fuzzing script in Python. We have variable buffer equals a, counter 100, and below counter equals counter plus 200. So we'll send against the target IP, we'll send against this target IP in port 110 in command pass a lot amount of character A. We have two commands here, command user and command pass. But we have here 4 string in buffer and in command pass plus string. So we'll send in command pass this a lot amount of character A. We'll send in command pass a lot amount of character A, with objective of cause a crash in protocol POP3. You send against this target IP port 110 into a command pass plus string. You send a lot amount of character A in command pass. So let's send the Python fuzzing script. Was sent 5,900 bytes of character A's in port 110 of target IP. And as we can see, the port 110 is down. Port 110 is down because caused a crash in service POP3. Let's continue with our slides. Here we have enable software to download. Here we have another POC. Here we have enable software to download immunity debugger. We will use immunity debugger for debugging a vulnerable software. Let's see another video POC. Let's open our exploit code. Here we have a variable buff size with 50 downstairs bytes, variable buffer with a lot amounts of these characters. This a lot amounts of characters was generated by two pattern creator. Here we have output file. This a lot amount of this character will load in vulnerable software. Will load vulnerable software. It's a lot amount of character with objective of cause a crash in vulnerable software. For generate a lot amount of character, we will use a tool pattern create. Pattern create dash L the length 50,000 bytes. 50,000. And we have this a lot amount of characters. Let's copy this allotted amount of characters and paste in our exploit code. Copy and paste this allotted amount of characters in our exploit code. Let's compile our exploit code with per and the name of our exploit code. We have the output, our compiled exploit code. Let's move to a desktop our compiled exploit code. Move to a desktop. Let's copy our compiled exploit code to a victim VM. Let's open Immunity Debugger and run a vulnerable software. Let's attach our vulnerable software. Let's attach our vulnerable software in Immunity Debugger. Let's run a vulnerable software Immunity Debugger. And now let's load our compiled exploit code in vulnerable software. And we have in register ISP a lot amount of characters because occur a stack overflow in vulnerable software. For this we have a lot amount of characters in register ISP. And we have a value in register EIP. The register EIP indicates the next address of the processor will execute. Again, the register EIP indicates the next address that the processor will execute. For this, we want to find an offset of register EIP. For this, we will use a tool pattern offset. Pattern offset -L 50,000 key and the value of the register EIP 79 53 35 1979. A pattern offset -L 50,000 of link key and the value of the register EIP, and we found offset 35,056. We found offset 35,056. So now let's open our exploit code. Let's open our exploit code. Here we have variable buffer size with 50,000 bytes. Below variable junk equals x41 multiplied by offset of EIP. x41 means character A. x41 means character A. We will fill with character A up offset of register EIP, offset that is 35,056. We will fill with character A x41 up offset of register EIP. Remember that the register EIP indicates the next address that the processor will execute. And then we have a variable IP with a value that we will find. Jump ISP. We want to find an address that make a jump from IP to ISP. Again, we want to find an address that will make a jump from IP to ISP, because in ISP we will put our shell code to get a reverse shell. Again, in ISP we will put our shell code to get a reverse shell. For this, we need to find an address that make a jump ISP, jump from IP to ISP. So let's type in command bar mona modules, and we need to find a module without secure mechanisms. We need to find a module with safe SE8 as false, ASLR as false, NX-compate as false. We need to find a module with secure mechanisms as false. And we found a module msvols.dll. We will use a module msvols.dll. Now let's use a tool NASM shell to find the opcode for jump ISP. Let's use a tool NASM shell for find the opcode to jump ISP. We want to find an address that make a jump ISP inside the modules msvols.dll. And we found the opcode FFE4. FFE4 means jump ISP. Again, FFE4 means jump ISP. Let's type in command bar exclamation find -s, the search FFE4, that means jump ISP, -m, the module msvols.dll. So we want to find the mona, exclamation mona. We want to find a search jump ISP as FFE4, that means jump ISP, inside the module msvols.dll. We want to find a jump ISP that is FFE4 inside the module msvols.dll. And we found the module, we found the address 01BA135B. We found the address 01BA135B. This address 5B13BA01 is an address that make a jump ISP, because we want to make a jump from IP to ISP, because in ISP we will put our shell code. So we typed here a jump ISP address 5B13BA01. It's a jump ISP address. So now we need to find a bad characters, bad shards. We will load in variable software the bad shards 01, 02, 03, 04, 05 up FF. We will load all these characters of bad shards in vulnerable software with the objective of finding some errors. Let's understand better what means bad shards. Now we need to search for bad characters. Depending on the application, types of vulnerability, and the protocols in use, maybe certain characters which are considered bad and should not be used in your buffer or shellcode. One example of bad characters is X00. This character is considered bad because a null byte is also used to terminate a string copy operation, which would truncate our buffer whenever reaching the null byte appears. So, has some characters that are considered bad and should not be used in our buffer or shell code. So now, what we want is we want to find these bad characters. For this, we load all these characters in vulnerable software with objective of finding the bad characters. So let's save our exploit code. Let's compile our exploit code. Let's move our compiled exploit code to our desktop. Let's restart our immunity debugger. Let's run our vulnerable software immunity debugger. So let's copy our compiled exploit code to a victim VM. Let's click it with the right button, go to expression, and we want to find an address of jump ISP 01BA135B. It's an address for jump ISP. We want to find the address for jump ISP. We found FF for jump ISP. So we found either jump ISP, jump from IP to ISP. From ISP we will put our shell code. Let's double click in FF4 to put a breakpoint in jump ISP. Let's put a breakpoint in jump ISP. Let's load our compiled exploit code in vulnerable software. And the process stopped in jump ISP. Process execution stopped in jump ISP. So now let's right button in ISP following dump. Let's click with right button in ISP following dump. And we have in dump a value 01, 02, 03, 04, 05, 06, 07, 08, and after 000000. We have some error here because should it has here this all this content 09, 0, 10, 11, 12, 13 should have here all these values of bad shards, but in this case occurs some error because after 08 we have 000000. Occurs some error here because we have some bad shards. Let's open our exploit code again. We know that the bad shard in this case is 0A. 0A and 00. Bad shard in this case is 0A and 00. For let's erase 0A. Let's erase 0A. Save the file. Compile, export code again. Compile, exploit code again. Move it, exploit code to a desktop. Let's restart our immunity debugger. Run vulnerable software immunity debugger. Click right button, go to expression. Let's find the jump ISP address. Put a double click in FFE4 for put a breakpoint in jump ISP. Let's put a breakpoint in jump ISP. So let's copy our compile exploit code to a victim VM. Let's copy our compile exploit code to a victim VM. Let's load our compile exploit code in vulnerable software. Here we have stopped in jump ISP again. Stopped in jump ISP. Let's click with right button in ISP, following dump. Let's see the dump. Now we have the dump 01, 02, 03, 04, 05, 06, 07, 08, 09, 0B, 0C, 0D, and etc. Up FF. So in this case we don't have a 0A because 0A and 00 is a bad characters. Again, 0A and 00 are a bad characters. Now that our take out a 0A, we have the continuing values 0B, 0C, 0D, 0E, 0F, and etc. We have all these values. We have all these values up FF 0 since 01 up FF. We don't have 0A because 0A is a bad characters, but we have after 9 we have 0B, 0C, 0D, 0E, 0F, and etc. Up FF. So now we discover that the 00 and 0A are a bad characters. Let's restart our immunity debugger. Running a vulnerable software immunity debugger again. Click right button, go to expression. Find our jump ISP address. Let's put a breakpoint in jump ISP with a double click in FFE4. Put a breakpoint in jump ISP with double click in FFE4. Now let's generate our shell code. Let's generate our shell code to make a reverse shell, to get a reverse shell. For generate our shell code, we will use a tool MSF Venom. We will use a tool MSF Venom. So you should type msf -p payload shell versus TCP lhost of localhost IP address lport 5555-f of file per -e of encode shikataganai -b of bedshar 0a00. So will you generate our shellcode without bedshars B0A00? Will you generate our shellcode without the bad character 0A00? Will you generate our shellcode without bad characters 0A00? Let's open our shellcode again, our exploit code. So we have a buffer size 50,000, variable junk, x41, that means 8, multiplied by offset of register IP. We will fill with x41, that means character A, up offset of register IP, that is 35 down to 56. After we will overwrite register EIP with address 5B13BA01, that is the address that make a jump ISP. We will overwrite variable EIP, we will overwrite register EIP with address that make a jump ISP. After we will put in ISP some loops, that means no operation. 90 means loops, that means no operations. We will fill register ISP with some loops, and after we will put in register ISP our shell code. So we will overwrite the register EIP with the address that make a jump ISP. As we will put in register ISP some loops, that means no operations because do nothing. Loops do nothing. And after we will put in ISP also our shell code. So let's erase our old shell code to put here our new shell code. So let's copy our new shell code. Copy our new shell code. And paste our new shell code in our exploit code. And paste in our exploit code our new shell code. So we will fill in variable junk, we will fill with character A, that means x41, up offset of the IP, that is 35 down to 56. After, we will override the IP with the address that make a jump ISP. We will override the IP with the address that make a jump ISP. Doing jump ISP, we will put in ISP some loops that means no operations because do nothing. And then after, we will put in ISP our shell code that for make a reverse shell. We will put in ISP our shell code to make a reverse shell. We have variable exploit, junk concatenated with IP, concatenated with loops, concatenated with shell. Exploit equals junk will load invulnerable software junk concatenated with IP, concatenated with loops, concatenated with shell. Let's save the exploit code. And let's compile our exploit code. And we have a POC file. Let's copy a POC file to a desktop. So let's put a netcat to listen on port 5555 with netcat-l nvp listen on port 5555. And let's copy our POC file to a victim VM. Let's copy a POC file to a victim VM. So let's load our POC file in vulnerable software. As we can see, it stopped in jump ISP address, EIP that indicates the next address that will execute is stopped in jump ISP. Click with the right button in ISP following dump. And we have here our loops 90, 90, 90, 90, our loops that do nothing, our loops that do nothing, and after our shell code. We have here our shell code BA B097. Here we see following dump BA B097 and etc. We have here our shell code, our loops, and after our loops, our shell code. Our shell code. Let's run our vulnerable software with play. And we got a shell. Let's see the IP address IP config. We see our IP address of victim VM. Net user with our users, ROd0X and administrator. Is it. We have here in these slides step by step of the whole process of how you can write your own exploit code. We have step by step the whole process of how you can write your own exploit code. Now I open for questions. Thank you very much, everyone. Now I open for the questions. Thank you very much.